Hey everybody, this is Larry. This is day 10, day 11? Oh, day 10 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's poem. Still in Medellin, still working on that pronunciation. Though I've been practicing Spanish with the local Uber drivers, but we'll see how that goes. Anyway, today's poem is 560, subarray sum equals k. Given an array of integer nums and an integer k, we know the total number of continuous subarrays whose sum equals to k. Okay. This one is actually, it's kind of funny because I think we talked about, I don't know if you watched the video yesterday, but so I'm speaking as if you watched the video yesterday, but yesterday I did spend a good amount, was it? I think it was yesterday, maybe the day before, but either way, was it? Yeah. Talking about this idea of having a sort of what I call prefix dynamic programming, where you have this idea of looking up the past and also updating it with the current thing so that you can read it in the future, something like that, right? This idea of a lookup table that you kind of go process as you go from left to right, and as we do, this is apparently it comes up, and the main core part about this poem and the idea is prefix sum, and then from that it's just about doing the same math we did yesterday. So this is actually a great progression. So hopefully you get, excuse me. So hopefully you got this one correct, or get the idea. Prefix sum is an interesting concept. Maybe I need to do its own video at some point. But the idea is that I've done this a lot in previous videos, so hopefully I don't need to go about that much, but maybe I do for a little bit. But the idea is that, okay, you have sum a sub 0 plus a sub 1 plus a sub 2 plus a sub 3 dot dot dot, oops, plus a sub k, right? Or not this k, but let's say k sub I, right? A sub I, sorry, not a. And then we have the same thing, but for j, right? Actually, technically, let's just do I minus 1. So let's do that here as well. Plus dot dot dot, or well, plus a sub I plus dot 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 plus a sub j, right? So then if you only want the sum between two numbers, let's say you have some a sub I, oops, right? Then this is just equal to this formula minus this formula, right? If you kind of line them up and then subtract them, you end up with this, right? So that's basically the idea behind prefix sum, is that you're able to use this idea. You could build this obviously in linear time, and as you do from left to right, you can always look up the sum between any two subarray or subsequence, right? So that's basically the idea. And here we return the total number of continuous subarray whose sum is equal to k. That means that we're trying to find some a sub I to a sub k is equal to k. And of course, if we have a sort of a rolling counter, then we already have this number. We just have to find an instance, or maybe a number of count where in other words, you have to try to find another a sub I where this is equal to k. And of course, you could do some math, which we will do in a second, to get previous answers, right? For example, now let's see. So we're trying to find all i's where this is true. So there can be multiple i's, right? So all i's where this is true, right? So there definitely can be multiple i's, and that's basically the idea. And okay, and yeah. So then now we have this number because we keep track of the prefix, and then now we know that this number, we know that, okay, let's just call this equals, let's just say f sub j, and this is f sub I minus 1, say. We know that f sub j is equal to some number minus f sub some I is equal to k, right? So that means that, technically, I guess I minus 1, depending on how you want to define it. But, just flipping some signs around, you can, move this to the right. So, you add this to both sides. And then, of course, you subtract k from both sides. This is elementary math. Oops, 1. Lock myself out. Hopefully this is, again. Hopefully this is obvious manipulation. And then now you have this. So now we just need a lookup table for this, right? And in fact, we can also just keep track of how many times this shows up. And that's pretty much all the problem there is. And hopefully this is instructive. So yeah, so let's say prefix, maybe we could say prefix scene. Maybe that's a good way of doing it. And if you watched the video yesterday, I urge that you do, because even though I solved the wrong problem, the idea, the concept is the same that we use here, right? And then we start at, okay, so let's just say current is equal to 0, and also prefix scene of current increment by 1. So here we just basically allow the 0 element to be matched, because that just represents the no set, right? So that's an idea anyway. Cool. Okay. So then now we just have to go through the numbers one by one, right? Or something like that, right? So that's definitely what we want to do. And then of course, in the meanwhile, we have to look up what we said, which is, let's say previous is equal to, in this case, f sub j is current, of course, and then minus k. So then now total prefix scene pref. Of course, technically, just as an implementation trick, you should also check that this is in prefix scene, because if not, it will create this by default will create an entry if previous doesn't exist. So technically you save a little bit space, and then at the very end you just return total, and that should be good. I said that last time and I misread the problem, so hopefully I didn't misread the problem this time. Looks okay here. Are there any more tricky questions? Let's actually try this, but perhaps with more numbers, because why not? Let's see. How many numbers? I guess that should only be like n-1 or something, n-2, something like that. So it's not actually that bad. You can maybe even, I guess a trick or a fun case anyway is something like this. And because then this should be n squared roughly, or n choose 2 technically. And that seems to be right, so that should be okay. Okay, let's give it a submit. Hopefully it's good. Hopefully edge cases are always weird. Okay, cool. So this is good. It's a little bit slower than I did previously, but 681 day streak, and here we go. Yeah. So what is the complexity here? And this is also, just to be clear, something that I could very easily see on an interview. I think it's a little bit trickier, but I also feel like that is the meta these days in terms of the problem, difficulty, evolution. So I don't know. This is my opinion. I don't know that I've seen any problems like this per se, but yeah. Let me know what you think. This is going to be linear space, because this counter can be up to linear if nothing is matched. And of course, this is just O of 1 per iteration, and there is O of n iterations, right? So this is going to be linear time. And that's pretty much it. Linear time, linear space. And for fun, let's see what I did previous years. Okay, so I did the same thing pretty much. Though I probably explained a little bit less. I don't know. Let me know what you think. Okay, this one I actually mostly did the same thing as well. I didn't use counted out, but yeah. Okay, cool. I think that's all I have. I don't know if there's anything else. So let me know what you think. Stay good, stay healthy, to good mental health. And I'll see y'all later. Bye bye.